in the 1960s via the Dragon reactor. There are other options that are available to us, which we are in danger of overlooking. Foremost of these is a British design for a molten salt reactor described as the Moltex Flex reactor. This reactor has an inner core in the form of a collection of fuel rods that contain a salt uranium reagent, and its cooling circuit, which transfers the power to a heat exchanger, also contains molten salt at a temperature of 750 degrees centigrade. The outer cooling circuit is powered solely by convection, with an absence of valves or pumps. And the reactor is inherently safe. If, for some unimaginable reason, the reactor were to rupture, then the escaping salt would quickly crystallize at a temperature of 550 degrees centigrade. A single Moltex Flex reactor would produce 40 megawatts of energy, and it would be deployed on its own in an industrial application which might use its heat or a combination of heat and electricity generated by steam using turbines. And an electrical power station might contain a battery of 32 such reactors. The Moltex Flex prototype could be up and running before 2030. Therefore, it seems to me to be unaccountable that it has not also been considered as a front runner. I have difficulty in understanding this. I presume that in the minds of the civil service, the advantage of the X-energy reactor with which the Moltex Flex might be compared is that it is receiving funding from the United States Department of Defense and from the Department of Energy. Also, if the X-energy reactor were to be adopted in the UK, then there would be some inward financial investment. But these are insufficient reasons for failing to sponsor a native design. Yet I believe that they are typical of the thinking of the civil service and of the government. There are three distinct purposes that can be served by the various designs of nuclear reactors. First, we need nuclear power stations that contribute electricity to the grid, and various reactors are on offer for this role that are mainly pressurized water reactors. At one end of the spectrum are the EPR reactors rated at 4,500 megawatt thermal power, which are to be deployed in the mega power stations of Hinkley C and Sizewell C. And at the other end of the spectrum are the small modular reactors of Rolls-Royce and GE Hitachi. We should persist with Hinkley C and Sizewell C, but they should be succeeded by a fleet of SMRs from Rolls-Royce, which could be distributed widely throughout the country. Next, there is a need for a much smaller reactor for powering industrial processes, and the Moltex Flex reactor should be chosen on the grounds of its simplicity and robustness. And thirdly, there are fast reactors that are capable of burning the stocks of plutonium and of consuming other kinds of nuclear waste. And the GE Hitachi PRISM reactor, which is finding favour in the USA, could be an appropriate choice. I must ask the Minister to reveal the government's appraisal of these opportunities, and I seek an assurance that they will take steps vigorously to support our native endeavours, which include the Rolls-Royce SMR and the Moltex Flex reactor.
Week before last, I was